Question 3C asks us what vector describes the translation from S to T. So in order to do this question, let's go to our plane and let's draw the vector now that starts at S and ends at T. That means that the tail is at S and the head is at T. Let's draw that vector. Okay. And we've got to find the expression in terms of the bracket notation. So let's figure out, first comes the x direction. How many, we're going from S to T, so we have to move left, right? We have to move in the negative x direction. 1, 2, 3, 4, 5, 6 units. That would be -6. And then we have to go down from there, and the negative y direction we have to move 1, 2, 3, 4, 5, 6, 7, -7. Okay, so that is our vector. It's -6, -7. Notice that this can also be gotten in another way. We're going from S to T. Notice that if we look at the value of T and then subtract from it, coordinate by coordinate, the value of S, we will get the same result. So T is -2, -3, and S is 4, 4. So if we subtracted -2 minus +4, that would give us -6. And if we subtracted -3 minus +4, that would give us -7, which is the same thing as what we got here for our vector -6, -7. D asks, what vector describes the translation from Z to S? So we're starting at Z, and we're ending at S. You may notice that you should notice that this is a vertical vector. It has no x component. It only has y direction in it. We're going straight up from Z to S. Okay, so the x component is 0. We're not moving to the right or to the left at all, and instead we're moving only up 1, 2, 3, 4, 5, 6, 7 in the positive or up direction. So that vector would be angular bracket 0, 7. Again, if we did S minus Z, we should also get 0, 7. So let's do S minus Z. S is 4, 4, minus Z, which is, shouldn't have put a line there, 4, -3. So 4 minus 4 is 0, and 4 minus a -3 is +3, which is 7, and we get 0, 7. Okay, good. Let's go to E. E is asking us to translate point W using this vector. And this vector is telling us that we're not moving at all in the x direction, but we're going to move 5 units in the positive y direction. So this translation is acting on point W. So let's go ahead and do this. So we're starting with W. We're going to go up 5. 1, 2, 3, 4, 5. Takes us right to there. Let's draw the vector, just so we have a nice reference here. We've gone from W to W prime. Let's call this W prime, and our coordinates were -6 on the x, and we're 0 on the y. So the ordered pair for point W prime would be -6, 0. Does W equal W prime? Well, W is negative 6 comma negative 5, and W prime is negative 6 comma 0, so no, they're not identical points. So question F asks, in a translation, when is it possible for the pre-image to be the same point as the image? Well, the only time that can happen, since a translation is always going to move the point a certain amount of distance, which means that the image is never going to be the same as the pre-image unless the distance is 0. Okay, so if the distance is 0, which means that the vector has 0 length, then it is possible for the pre-image to be the same point as the image, and that would happen when the vector of the translation is 0. It's the only time that could happen.